This is my solution to the hard daily integral on the 12th of May. I'm going to start by finding an expression for this part. So I'm going to rewrite this as y is equal to square root x to the 2 minus 1, so that's 1 plus square root x to the 2. Now, initially when I tried to solve this, I made some substitutions, but you end up doing the same thing. So if we multiply through by x, we get x times y is equal to x times square root x. 1 plus square root x. This should be in this x. This will become an x squared. And the x squared will come here as well. Then this will become an x to the 4th in here, which will have an x to the 4th here, become an x to the 8th, and so on. So we're going to get x times y is equal to square root x cubed plus square root, so 3 plus 4 is x to the 7, plus square root x to the 15. Which, and so on. And this is perfectly equal to this bit. So this is equal to our xy. So you can write y is equal to square root x plus xy. Squaring both sides, we'll get y squared is equal to x plus or minus square root of x squared plus 4, because this must be greater than 0. So y must be greater than 0, and since x is greater than 0, this must be a positive, because this will be as the integral from 0 to 1 of x over 2 plus the plus square root x squared plus 4x. Now we can do a trig sub here, so we're going to get, I'll write this over here, so we're going to get as x plus 2 squared minus 4. From 0 to 1, we can set that secant theta to secant theta is equal to x plus 2. Then we get x is equal to 0, theta is equal to 0, and x is equal to 1. We're going to get theta is equal to inverse secant of 3 over 2. So now we're going to get 2 times secant theta tan theta. The theta is equal to our dx. And now we can plug this all in, so we're going to get secant 2, we're going to get 1 over 2, 0 to 1 of 4 secant squared theta minus 4 times secant theta tan theta. The theta is 2 now, so we get the hedge out there, and so we're going to tan theta. So we get 2 from 0 to 1 of secant theta tan squared theta, which we can write this as secant squared theta minus 1. So we get 2 times integral of 0 to 1, 0 to inverse secant of 3 over 2 of secant cubed theta minus secant theta. And then we can write this one out as so 2, and then these are the standard results. So we're going to get secant theta tan theta over 2 plus ln of secant theta plus tan theta over 2 minus ln of secant theta plus tan theta, which will simplify down to secant theta tan theta minus ln of secant. Put that into our calculator, we're going to get I is approximately 0.96, which is indeed the correct answer. Thank you guys for watching. Drop a follow, drop a like.